Welcome back. I had to, because I was hitting against the YouTube 10-minute limit. But all I was saying is we said, cosine of minus a. So I drew, a right triangle with a, and then I showed you minus a, and I said, well, all of the lengths are going to be the same, but now the direction of, and we're kind of assuming this is on the unit circle. If you don't remember the unit circle, maybe you'll want to rewatch the videos we have on that. But I'm just showing you that the cosine of minus a is equal to this side over the hypotenuse, and this hypotenuse is the same as this hypotenuse, right? So cosine of minus a is adjacent over this hypotenuse, while cosine of a is adjacent over this hypotenuse. But it's the same thing. So we know that cosine of minus a is equal to cosine of a. And actually, by definition, that makes it I don't want to confuse you too much, but that makes cosine an even function. And I'll show you more. Actually, I should do a whole presentation on even and odd functions. Now let's see what sine of minus a is. Sine of minus a is equal to, so this is minus a, so it's this side, so it's the minus length of, let's just say, let's call this x, let's call this y, and let's call this, well, let's leave that h, right? If that is x, this is y, this length is y, then this length right here is minus x, right? So the sine of minus a is minus x over h. Minus x over h, right? What's the sine of a? Sine of a is equal to, this is a, opposite over hypotenuse, x over h. It's x over h, right? So sine of minus a is equal to minus 1 times x over h, right? Or this is just the same thing as, if we could multiply both sides of this by minus 1, minus x over h, right? So sine of minus a is equal to minus sine of a. So let me clear this out and rewrite this identity. And as you can see, all I'm doing is I'm just playing around with triangles and showing you that just using the basic SOHCAHTOA, you can actually discover a whole set of trigonometric identities. So let's clear that. And you might. So a lot of these it is useful to memorize. I normally don't advocate memorizing, but it's helpful just to do things quickly. But I'd also advocate being able to prove it to yourself. So if you ever forget it and you don't have a cheat sheet available, you can prove it and if you ever have to teach it, then you'll be, I think, able to explain the underlying themes a little bit better. So let's clear this. Let's see if we can discover some more trig identities. So we know that. So let's see if we had sine. What's sine of a plus pi over 2? A plus pi over 2. Well, we could use our handy sine of a plus b identity, which we have already proved, so we can use it now. So that tells us that it's the sine of a, that equals the sine of a times the cosine of pi over 2 times the cosine of pi over 2 plus the sine of pi over 2. And we're in radians, of course. This could have been 90 degrees instead if we wanted to be in degrees. Sine of pi over 2 times the cosine of a. Right? Well, this equals the sine of a. What's cosine of pi over 2? Or cosine of 90 degrees? Well, that's when we're on the unit circle, we're pointing straight up. And so the x-coordinate is 0. I could draw it out, but I think you might want to draw the unit circle and figure it out for yourself, or if you don't, use it on a calculator. But you will learn that it is 0. Cosine of pi over 2 is 0. Plus sine of pi over 2. For the same reason, we're pointing straight up on the unit circle, so the y-coordinate, or the sine coordinate, is 1, right on the unit, at 1. We're essentially the point 0, 1 on the unit circle. So sine of pi over 2 is 1. So then, and then times cosine of a. So sine of a times 0 is 0. 1 times cosine of a is just cosine of a. So we have a new useful trig identity. Excuse me. Sine of a plus pi over 2 is equal to cosine of a. Fascinating. So really, this is just telling us that cosine of a is the same thing as sine of a shifted. So if we were to think of this graphically, if we were to think of, if we were to draw the graphs, if you shift the sine graph to the left by pi over 2, you get cosine. You get the cosine graph. And if you haven't learned about shifting yet, don't worry about that. Or you might want to actually graph the two, and I think you'll get a sense of what I'm saying. So let's do, I don't know. Well, another way to rewrite this exact same thing is the sine of A is equal to the cosine of A minus pi over 2. Right? If you just, let's say I said that B is A plus pi over 2, right? Let's say I said B is equal to A plus pi over 2. Then we could say that this is, this is B, and then this would be B minus pi over 2. I'm just switching around variables. I'm doing this in a much more loosey-goosey fashion than I normally do a lot of the videos. But I want to show you that a lot of this trigonometry can just be, it's just kind of discovery. What's sine of A minus B? Oh, that looks like a new one, doesn't it? Well, let's try to figure it out. Well, that equals sine of A cosine of minus B plus sine of minus B times the cosine of A. Right? Well, what do we know about the cosine of minus B? Before I cleared the screen, we just figured out that the cosine of minus B, since it's an even function, is the same thing as the cosine of B. So we can rewrite that as that equals the sine of A cosine of B. And then what's the sine of minus B? Well, that's the same thing as the minus sine of B. And that's what we just proved, that the sine of minus B, that this is equal to minus sine of B. You could draw out the triangle and the unit circle if you don't believe me, but we just did that. So then we could say that that is equal to minus sine of B cosine of A. Interesting. I encourage you to do the same thing with the cosine of A minus B. These are all just, we're using, 1 or 2 or 3 trig identities together and trying to come up with new things. And I think at this point we've literally gone over everything, that almost every trig identity you've seen in your book, you should be able to get there somehow just by keep on playing. And obviously all of these identities, you can invert the sines and the cosines and the tangents, and you can get identities for secant and cotangent and cosecant and keep playing around. And I encourage you to do so and do it graphically. Draw the triangles. It's also interesting to sometimes actually draw the graph on the xy plane of, say, cosine of x plus pi over 2, or cosine of x plus pi over 2, or sine of x. And I think I'll in the future do a video where I really do explore all of that. Well, I hope I haven't thoroughly confused you. I want to just kind of show you that a lot of trig, it's really, it all comes from SOHCAHTOA and playing around with SOHCAHTOA and triangles, and you can pretty much solve for everything you learn in trigonometry. And if you don't have SOHCAHTOA, at least the unit circle definition, which is actually better because it's more extensive. But anyway, that's all for now. See you soon.